Welcome. Let's look at quadratic functions. A review, really, because everyone's seen this so far. We're going to look at the vertex form and the standard form. Okay. And in the vertex form, we have it with the square here, x minus h, and the k on the outside. So we have an h and k. In fact, let me focus on the h and the k. There, get all this stuff back to it. I don't want it. So for the vertex form, it has a vertex in it. In fact, the h and the k, there, okay. H and k are the vertex. The standard form, we don't get the vertex immediately directly from it, but we can use this formula when in standard form, which gives us the h. And then you can plug that back in as the x. If you plug that back in as the x, then you indicate it here, then the result will be the k or the y value. Okay. Now, if we were to graph it, the a, if we were, actually this one here, the a here would help you with adjusting from the vertex, which is why I put that part there. Well, we're going to focus on right now is finding the vertex in both of these. First one, take the opposite sign, so we have a positive 3, and we keep whatever sign is there for the k. So the vertex for this one is 3 and 2. Okay, simply because that's h and that's k. Now, so there's one thing, remember opposite sign. So opposite sign. In the second one, in order to find the vertex, it's two parts. Or two steps. Vertex. Step 1, the x of the vertex is equal to negative b over 2a. Okay, so since this is b, negative 12 over 2 times 2, and a is here. Notice c is not part of it. We only need a and b. So what we get here is a positive 12 over 4, which is equal to 3. So once we get that x is equal to 3, now we need the y value. Okay, and that's actually h here. Okay, so let's put the 3 back in. So what we get is the function at 3 is going to be equal to 2, 3 squared, minus 12, 3 plus 14, using this formula here, or this the expression up there. And now I'll calculate it out. So the function at 3, we have 9 times 2 is 18. And then minus 36 plus 14. So then we get 18 plus 14 is 20. 32 minus 36 is a negative 4. So we get, and that's the k. So we get 3 and negative 4 for the h and the k. So we've just found the vertex here. So that's the vertex for that one, and this is the vertex for this one. Okay, and in fact, that one I ought to do this with also. Now let's graph B. Here we have B. We now have the vertex, the starting point. So let's go to 3 and negative 4. 3 and negative 4. Starting point there. So at this point now, if we're graphing it, now we can check some points back. Okay? And the best way to do this is you have a couple of ways. Making an XY table works really well. The other thing to do is, if you can easily do it, find the 0. Find the zeros, or at least, well, you can find the zeros when y is 0, or the y-intercept. Y-intercept one could be easier here, because for the y-intercept, what you're doing, that's when the y is 0. So I'm going to do that the function when x is 0, I should say. So here at this point, this is the y-axis, but it's also the line of x equals 0. So let's take it, and we're using this one here. 2x squared minus 12x, so it's 2 times 0 squared minus 12 times 0, and then it's the plus 14. So what this one does here is tell us that the function at 0 is equal to 14. Well, we get the point 0 and 14. So right now, when I look at this, this only goes up to 10. So I'd have to go a few more and estimate where it is, which I could do. But now that's one thing. If this had been 0 and 4, I would have gone here and it would have gone a matching 4 over here. And then I would have been able to draw it. Unfortunately, it's not quite there. So what instead I want to do is to do a couple of points. So like this point here, the vertex, that's where x is 3. Well, let's do a couple others. Let's do where x is 1. So we didn't know that at 3 we're at negative 4. So let's do 1 on both sides. Let's go to 2 and 4. So that's a matter of using that formula. The f of x is equal to 2x squared minus 12x plus 14. Just checking here. Yep. So if I put 2 in here, I get 2 squared minus 12 times 2 plus 14. 4 times 2, this is 8, minus 24 plus 4. That's 12 minus 24, which looks like a negative 12. Okay. Ooh, no, something's off here. I think it should be positive. No, I don't see anything off on here. So I just think I have a number wrong. 4 times, oh, it's 14. So you would put 14, but I forgot to do the 1 down here. So what that actually is, let's fix the rest of this. 14 plus 8, 22. So that means we have 22 minus 24, so it's a minus 2. Over here, that's not a negative 12, but rather a negative 2. But something seemed weird on it because that would have had it going down. That's why oftentimes when you make an error, if you just keep thinking a little bit about what you're looking at, you might catch your own error. So I'm going to go to 2 and negative 2. And with 4, 2 times 4 squared minus 12 times 4 plus 14. Careful that one in now. That's 32. 16 times 2 is 32. Minus 48 plus the 14. So 46 minus 48. Ooh, looks like we have another negative 2. Okay. So that means there's reciprocity. No, rather not reciprocal, but rather symmetry here between the two and the 2 on the 2 sides. So that means I really only need one other. 1's easy to work with, so let's do 1. 2, 1 squared minus 12 times 1 plus 14 gives me 2 minus 12 plus 14. That's 16 minus 12, which is a negative, not a negative 4, so it's a positive 4. 16, take away 12 is a 4. So at 1, we're up to 4. And that means on the other side, we would have the same kind of thing. So if here we go over 2 and it's up to 4, over 2 and up to 4, then that's what I want to show. And now I can draw an approximation of this. Would have been much easier to do if this other point had been easy enough to do, if it had been under 10 or under. But since it wasn't, I can do a few points over here and get very close to where this should be or how it should look. Let me make this a slightly better one. All right, I didn't draw that very smoothly down here, but you have the idea of what the graph of it would be. And it starts with having this vertex to work with, 3 and negative 4. Now let's look at an application problem. Football thrown by a quarterback to a receiver 40 yards away. This function models the height above the ground in feet when it is t yards from the quarterback. Ooh, now we have feet in yards. State the number of horizontal yards from the quarterback when the ball reaches its highest point in the air. Okay. So for some reason, S means distance. I would have thought D, like the distance formula, dt would work, but they just, someone somewhere decided not to. So we have to live with the consequences of that in the math world. Okay. S is distance. So based on the time, there's a certain distance that's traveled, and this is the formula. So what's happening here is there's a quarterback who farther down the field wants to throw to a receiver and throws the ball to the receiver, who hopefully catches it. And there's a highest point here. And what we want to know is what's that height. And we also want to know how many yards it is to get over here. So we want to know this distance, X yards. Okay. And this one in feet. So the highest point is the vertex, H and K. So what do we do to find this point? If we find that point, that will give us the y value and the x value, which gives us the height and the yards traveled to get to there. So we find the x of the vertex through x equals negative b over 2a. So here now we have b is 1 and a is this negative 0.025. Okay, so I'll put a 1 in there for that. So here we have negative 1 over 2 times negative 0.025. Okay. And when the negatives cancel out, and 2 times that is 0.05, 1 and 0.05. And then actually divide that and you get the number 20. So what this identifies is that here, this is a 20. This then is 20 yards. So what we need now is we need the y value, and we'll get the y value, or rather the h, by plugging it back into this. So S20, okay, that's that x is equal to 20 there, okay, or t in how they want it. Okay, so in this case, well, keep it like that. That's equal to negative 0.025. The t is 20 squared plus 20 plus 5. So the distance, okay, the height rather, well, the distance is a height, is equal to this whole thing. If you multiply that out and add 25 to it, you get the number 15. Okay. Now, that means we need to take that's in yards. So in feet, that's 45 feet. 15 times 3 feet in a yard. Oops, let's out. Make this a little bit better. Okay. So the number, so let's call this A and then this B. So for A, the number of horizontal yards is 20 yards. The height at the highest point, which is in feet, the height above the ground is in feet, That means we had to take the yards and multiply it by 3 to get the feet. That's 45 feet. Okay. Ooh, actually, the answer should be shouldn't be A and B. Okay, it should be that the 20 yards is the height, or is the horizontal yard, okay? Horizontal distance, and the 45 is the height. Okay, now. To another problem, a similar one underneath it, and it's about fireworks. Okay, now we have this equation. The distance, or rather the height, is going to be this negative 16 t squared plus 192 t plus 4. All right. So concept here, it is that fireworks are launched up, they explode, and then fall down. But over time, it's, if we look at this as time, then they're fired up and they get up to a certain point, and then they blow up. And if it continued, it would come down to here. Okay. Now, fireworks actually blow up, and then there's just little bits and pieces coming down. So what we want to know is this h, and we want to know the time here. Okay. So t is there. So the t, this part, because up here, that's the t, and then the height, or we call them x and y, or h and k. But here, there's too many h's in this. So that's why I'm going to do time and then height. And I think I'm going to make that so it's more readable. Okay, so the time for this vertex, this one is negative b over 2a. So here we have the b, and here we have the a. So it's negative 192 over 2 times negative 16. So the negatives cancel out. We have 192 over 32. And if you take 32 and multiply by 6, then you've got that. And the time is in seconds. So we now have 6 seconds it takes as it goes up. We want to know how the height is. Therefore, we're going to use that height, or that distance, is S6 equals negative 16 t squared plus 192 times 6. Oh, in fact, I meant to put, in place of the t, I meant to put the 6 here. A plus 4. So what's that come to? That's negative 16 times 36. Negative 30. Oh, no, 6 times 6 squared is 36. So negative 16 times 36. I would have to figure out more details on that. Right now, I'm going to jump to where if you calculate all that out correctly, you're going to get 580 feet. Okay. So that's the height. That height is this amount. And when should they explode? That was 6 seconds. Let's get this to cooperate. Well, maybe it's not going to. I'll just go around the edge. Ah, now we got. Oh. Okay, good enough for that. So those application problems show using the negative b over 2a format to help you get the x of the vertex and what it stands for. Here, there were specific meanings to that. A certain distance, or a certain amount of time, and the height, of course, in each one. Thank you for listening and watching. I hope this was helpful.